on the documentation. So the documentation is publicly available. You can see slides here. You can also see we have also like a PIC training. This is what we will be covering today. And we also have YouTube videos with similar talks. So that's what I didn't want to spend too much time on the slides. So it's actually better, I think, for you to make it interactive. So
yeah, I totally agree.
So yeah, just like overall, like the motivation of Gdsfactory is that all the tools based on Python, like GDSPy is very used in academic. There's a lot of NASCA. This was my experience also with DipKeys. It's slow for like flattening, reading and writing GDS. It can be very slow. With Gdsfactory, we are basically 200 times faster in some operations. And what I had to do before is do a lot of K-layout scripts to merge other parts. But now with Gdsfactory, because it's all based on K-layout, it's basically very fast and you can do everything on Gdsfactory. So Gdsfactory is basically K-layout in Python, with Python, using the Python API. So K-layout allows you to do the verification, but Gdsfactory allows you to drive design, allows you to drive verification. This is DRC and LBS. It allows you to drive testing, so you can do automatic testing. And it can accept, we have multiple PDKs from many foundries, so it also accepts PDKs from foundries. So the flow is basically you start with Python or a schematic. So you have a way to describe the circuits in scripts, or you can define them in place and route. You can run them through interpreter, and then you can create GTS. And it's very easy. Like you can just create a component, which is kind of like a canvas. And in the component, you can add references or you can add polygons. A reference is a pointer to another component. So you can define arbitrary levels of hierarchy. So it's fully hierarchical. It allows you to do very complex things. We also support many foundries. We have a schematic-driven layout. So we can do a schematic-driven layout from pure Python, from Cooks, from Xscheme, or from numerical interconnect. So we support 4 different schematic-driven layout flows. And it's all thanks to being able to output SPICE, convert the SPICE to YAML. The YAML is a YAML Gdsfactory. The format for the netlist in Gdsfactory is based on YAML, where we have instances, placements, and routes. And that allows you to fine-tune the placements. We can also, from Python, we can create GDS files. We can also create PCB boards. We can also create STL 3D printed objects. So this allows you to, from Python, be able to generate CAD files. But from Python, we can also generate simulations. So as a designer, I spend a lot of my life doing like layout, and then I do layout in, for example, like numerical or Tidy3D. So that duplicates your work. So with Gdsfactory, what we do is we have the component itself that you define. You can send it directly to a simulator without having to lay out twice. So that can reduce a lot of errors. That can be misinterpretation between what you simulate and what you end up fabricating. So this is basically an approach where it's basically layout-driven design. We have proprietary tool plugins, and we have also open source plugins. So this is, and the nice thing is that all these plugins that we have, and you can see we have a separate repo, maybe I can show briefly. So we have these plugins. The nice thing of this is that every of these tools that we drive with Gdsfactory have a different API. And it's very hard for a person to learn different APIs. For example, let's look at find a different time domain. If you want to use like Tidy3D, Meep, Numerical, or FTDZ, these have tools that have different API, have different like syntax. So you have to learn very different ways to talk to the tool. But with Gdsfactory, we made it in a way that talking to these tools is with the same syntax. So you can easily swap tools. So for example, you can use Tidy3D, but for example, if you want to use Numerical, the API it's very similar in a way that you can just take a component and then you can write GDS parameter. You can write the S parameters. So it's basically, they're almost equivalent. So you take a component, you basically create a simulation out of it, and then you can simulate these parameters. And all these plugins plugins are basically extensions that have a similar syntax. They're all part of the Gdsfactory plugins. And today we will be mostly using Femwell for finite element method. This is open source, but we will be also using Tidy3D for the mode solver. The mode solver is open source, so that's what we will be using. And we will be using SAX, which is a S-parameter circuit simulator. SAX is one of my favorite tools. It's open source, it's Pythonic, and it's fast. You can see that other simulators, other proprietary simulators, basically can crash if you have more than 1,000 elements. So basically, SAX can simulate more than 1,000 elements in less than 10 seconds. And basically, it's based on an open source machine learning library from Google called JAX. So it has just-in-time compilation. It has arithmetic that's differentiable, so you can propagate gradients for optimization. And it runs on CPU, TPU, and GPU. Another package I really like is Femwell. So Femwell is basically a finite element solver that can do multiphysics. So we can basically do heat simulations. We can also do basically lithium nanovate device example. I think you also guys work on polymer. So you can use them for nonlinear. It has different solvers like a Laplace, Coulomb, EM solver. So you can put basically all these equations, and I highly recommend also looking at the Femwell documentation if you want to learn more about the tool. A lot of people ask about co-simulation with electronics, so this is something that Gdsfactory also supports. And there's tools such as PIL, which is another package that we actually, there was a talk at the conference I'm currently attending in Paris, which is another talk about PIL from University of Bristol. This is from Dario Quintero. So the Gdsfactory is one of the tools that they use. The same with Femwell and SAX. So you can see that Gdsfactory and Femwell and SAX are used for photonic design, but you can also interface with analog design tools, and you can also interface with digital design tools and quantum tools. So this is a framework for co-simulation. This is also something we will be doing later today. We can also do verification. We can also write DRC text from Gdsfactory into KLayout. So this basically allows you to avoid manufacturing errors, such as minimum area, minimum width, minimum space. All these things you can code pretty easily in Gdsfactory. And you can also catch connectivity errors. And yeah, most of the people, as you will see in companies, you have basically three options. So you have the option of in-house development. This is basically if you develop your internal tool at the company, you're basically limited by your engineer's time. So this it can be a bit dangerous if the engineer who made the tool leaves or gets promoted or stops developing the tool. If you buy, you can be bounded by the vendor limitations and the number of licenses you have, or how much money you have for these licenses. But with open source, you basically get the free as in freedom and free as in cost. So you get the advantages of the collective development of the tool, and it's also extensible because you can customize it to your needs. And yeah, this is the project is we have more than 65 contributors, so I highly encourage also if you guys want to contribute, but you don't have to contribute. It's kind of like Linux. The fact that it's open source doesn't mean that you cannot use it for your internal project. So there's also a bit of misconception with open source, but yeah, I always tell like Linux and Python are open source, so those tools have benefit a lot from the community development. So yeah, I just want to thank all the developers of Gdsfactory that have made this project possible. So yeah, this concludes the 15-minute intro. Any questions before we start jumping into layout? No question?
We're keen to get into it.
What?
I think we're keen to get into it.
Oh yeah, okay, sure. Yeah, like first I wanted to do kind of like a 1 minute kind of like intro. Like for example, like I'm gonna do a pixel. You guys can see let's go to the P-cell demo. So I'm going to delete everything, and then we're going to start from 0. So the first thing we're going to do is we're going to create a canvas, a component, and we're going to add a reference to like let's do it a straight, and then look, let's do a bend, bend circular. So the way it works is like Gdsfactory, you can define a polygon, for example, this one, and you can do a layer. Let me see. And then what I'm gonna do you can do like c.write GDS, and then you can write it into GDS, but you can also show it. So the nice thing of showing it is that basically it will allow you directly to show it in KLayout. So you don't have to go to File, Open File. So directly we have something called KLive that will allow you to. We have this installed. It's called KLive. It will automatically, when you do Gdsfactory show, it will show the layout on your viewer, basically on your KLayout viewer. Something we also have is the meta ports. So whenever we add ports, this will be also very helpful to visualize the ports. So you can draw polygons, as I was showing here, but we can also draw like a straight, and we can also add a bend. So this is kind of like a very simple, like you see the polygon is kind of big. So you see here we have the name component. This is the canvas. And here we will draw a reference of a bend and a reference of a straight. So let me add the bend too. So if I run this code, you will see here we have a bend, a straight, and let me remove it to a different layer. We can also choose the generic tech to see the correct layer. So you see, I'm gonna run again the code by commenting the add polygon, or I can also move so I can call this straight. I can also call this bend. I can also move Y. Move it to, let's move it like, for example, like 10 up. And let's move the bend, move Y to basically. So these, because we're using the decimal, so you see we have the straight and the bend are now together. Something you can also do very easily is like, for example, like you can also do, let's do more complicated things. Like let's do like an MCI and a bend. So I'm gonna just do an MCI, and I'm gonna now I'm putting the MCI and the bend, and I'm gonna connect the bend, the port O. I can also do it a bit shorter. I'm gonna put the input of the bend to the MCI 01. So the output of the MCI. So what this is gonna do, I think, did I do it correctly? Yeah, I think it's not destination. This is yeah, if you use something like Copilot, sometimes you have to be careful because I think it's trained on a very old version of Gdsfactory. So I don't know if you noticed. Also, he was suggesting me the old port naming. But yeah, you can see here we have the MCI, and here we have the bend. And these components are basically based on the generic PDK. So Gdsfactory also has a very big generic PDK that you can customize for any foundry that you work on. And if you use any of the Gdsfactory PDKs, you will also benefit from all these generic PDKs adapted to all these technologies, because every PDK has a different. As you can see here in the generic PDK, every PDK will have a different layer number for the mask layers, and it will also have a different layer stack. So it will have different thicknesses, and what allows you to define the layer stack is that you can do like a 3D rendering after you finish, or you can also do like component simulations. So this is what enables to do with the plugins to do like thermal simulations, mold simulations, basically multi-physics design. You can see it's all in 3D. So what we're doing here, we're taking an MCI from the generic PDK and a bend circular, and I'm connected the bend circular here. But what the power of this is that you can create parametric cells. So let's make a parametric cell. MCI with pen, and I'm putting the same thing here, and I'm gonna use with main C equal MCI with pen. And let me know if I go very fast because I've done this many times. So what this is doing is that I have a function that can return this component, and I can do hundreds of this component. And the beauty of this is that I can pass things like radius, and I can pass the radius here. And so I can do, for example, radius 100, and now the bend won't be 10, it will be 100 bend radius. So it's very easy to define a parametric cell. Something that you will see when you look at Gdsfactory code is that to avoid this unname underscore 0, because we are not giving a name to this component, giving names is very hard in programming. Like giving names and caching are usually the hard programming thing. So we solve this with a decorator. It's basically a function. You put this thing on top of your function that return components, and this will basically automatically name your parametric cell with the parameters that we pass, or MCI with pen underscore RR 100, because the R is the radius, and I'm passing 100. Something you would like to do too is, like, as you define, you can do things kind of like when you connect things, you can also mirror equal true, and you can also, so basically this basically makes the bend face down, but you can also do it like in another way. So you can also be mirror. So you can also mirror before you connect. It's actually demirror. But yeah, it's the same. So you can also mirror before and then you connect. So that basically mirrors in x-axis. So the bend is mirror and it's facing down. And now we have a parametric say we can bring it back to 10. And then it will basically adapt to 10. Something you can also do, we can add ports. So if I want to interact with other things, like other components, I want to be able to route. So you need to define ports. So you need to do add port. I'm going to put the port of the MZI input and the second port and the pen output. So when you do this, nothing changes because the ports are something that is basically not stored. Actually, it's stored in the GDS, but it's not shown when you visualize the .save it. I mean, actually, it's a store. Yeah. So thanks to this meta port plugin, we can visualize the output input port and the output port. So you can see hide ports. And the nice thing of this is that I can even go to any component here and show the ports. I can do the MCI. And the MCI is also made of straights and bends. So I can also see the ports of every level. I can even see the settings. For example, this MMI, I can do user properties, and I can see all the settings that were used to do it. For example, I can see the length of the MMI is 5.5, the length of the taper is 10. So we can actually store the metadata of the GDS. And this will be very helpful when you want to test these devices. All the metadata will be saved also into the same file, into the same GDS file. And this is only since the Gdsfactory 8 update that we did a couple of weeks ago. So yeah, if you guys were using 7, highly recommend to update. And we also have a migration guide here to how to upgrade to 8. Because we also make improved routing as well. That will also, I can also show some of the examples. But now that we have ports, we can also, so this component, like if I run it, I have ports. So I can do another component that was basically C, GF routing, add fiber array. So I can arbitrarily add more complexity by calling another pcell that will add a fiber array to this component, and they will basically make it ready for testing. So if I go back here, you will have this component that has this MZI with a bend, and it's also ready for testing. So yeah, this is kind of like an intro to layout. If you guys have any questions about layout, we can go now. don't know if I was too fast or everyone good.
Maybe would it help if to just like paste that code that you used in the chat? We can kind of copy paste if we didn't catch it all and run it a bit while you continue. Maybe would that be helpful?
Yeah. This is done in the basically in the tutorial. The tutorial has all these examples of how to do like components with hierarchy and like straight with pins. Something. What I was thinking to continue is like we have this tutorial. Like basically, if you go to the Gdsfactory, let's go back to the Gdsfactory. We have on getting started. We have no, it's here at the bottom. It's on the Gdsfactory training. So we have a training that will basically guide you how to install K-layout on the computer, how to install Python if you don't have it. Just make sure that you are using 3.10, 3.11, or 3.12. It doesn't work on older versions because we use some of the new things. And you can download the whole notebooks. And this will basically have the layout tutorial. This has even more things that I show polygons. I didn't show like Boolean operations, but I show the connecting things. I show the show and hide ports. And this is basically how to print nice ports. And then the Booleans. And then we write to GTS. We already did that. And something you can also do is you can also write it to STL, like to 3D. So you can actually create 3D. If you want a 3D print at home with Gdsfactory, this is something that I know people who have done. We even did it in some of the Python conferences. But yeah, I think it's always kind of like if you use Gdsfactory, this may be a bit slow. But if you never use Gdsfactory, I recommend like just downloading the tutorial and just run it. And if you download it, basically it will be kind of like this. So you basically can download them as Jupyter notebooks, or if you don't want to install anything, you can also run it on Colab. So Google Colab is basically a way to run notebooks without installing anything. It's basically on your browser. This will basically open the notebook on the browser. You can even run all the things. This will basically, the first line will take some time because it needs to install Gdsfactory. But once this is installed, you will basically be able to do all the tutorial on the browser. And this is one of the powerful things of open source. Like I don't need to check out licenses or anything. And and you could download it and you can also run it offline. You don't need to have internet to do layout or. So yeah, any more questions?
Yeah, maybe I have one. In the tutorial, I highly advise to use Anaconda as a virtual environment, but do you absolutely need it, or do you have something to check if you use a standard virtual environment?
You can use any Python you want. Like you can, where are you, Mac, Windows, and Linux? What do you use?
Like right now, Windows. But,
Windows? Yeah, with Windows is the easiest with Anaconda. But I think now Windows has also WSL, like Windows Subsystem for Linux. So it has a Linux inside with Python already. You can also use, I think there's also a Python installer for Anaconda. Is kind of like what works on all the operating systems. So whenever we have to recommend something, we recommend something that we know for sure works in all operating systems. But Gdsfactory, I use it on all like Windows, Linux, and Mac. And I think it's the only tool who actually runs on Windows, Linux, and Mac. All the other ones don't work on all the three. So yeah, I highly encourage to install it locally, but you can also install it on a server if you want to share with other people. But it's also nice to like use like Git. But yeah, as I showed, you don't even need to use Git. You can also install it on Google Colab on a shared Google Drive. We also have introductions to Python and Git. This is also something I kind of like wanted to show here. We have how to install it, how to set up the Python editor, how to integrate it with Klayout, and how to use Git. And it will also show you kind of like different flows that we have. So we have the standard Python flow, the file watcher, or the schematic driven layout. Yeah, I highly recommend going through the tutorial. But if you think the tutorial is very deep into kind of like layout, you can just maybe, usually it goes from more simpler to complex. So maybe if you are doing like component and references, maybe you only need the 3 first. But if you want to do things like grids, like not all angle router, you probably need to finish this, or you can go all the way until the end. So it goes from simpler to complex, and it's all kind of like shown. And you can see we have can route to any complex. Can route like automatic to very complex. Yes. Yeah.
Yes, I installed Gdsfactory last night, but I have a problem running. So when I open the first layout tutorial, then I run the first script where you import Gdsfactory, and then it says module Gdsfactory has no attribute geometry when I run the script.
Which
other people are getting the same error.
Okay, which that's probably because you're using an old Python, so you're probably getting an old Gdsfactory version. Which Python are you using?
3.10.
3.10, and which version of Gdsfactory?
I downloaded it last night, so I assume the latest.
And you just download the. What are you running? Are you running the notebooks, or what are you running?
Yeah, I'm running a notebook. The 10_layout full notebook.
Okay, if you go to the Gdsfactory installation, like getting started, in the installation, I don't know if you can see my screen. Can you copy paste this? You would like to see? I would like to see which version of Gdsfactory you have. If you can get this, because yeah. It's not obvious that even though you installed it last night, you installed the right one, because some of the PDKs that we have, they have older versions, but I don't know. Yeah, last night you should have got the latest one. The geometry model was probably, I think it was only in 7, so I don't think you have 8.
Yeah, just a second.
And for example, like I would, if I run this, so if I go here, you will see that this basically installed Gdsfactory, and then I was able to run this right now. So are you running exactly this layout notebook?
I have Python 3.10.12 and Gdsfactory 8.1.0.
And what are you trying to run?
From VS Code, I opened the notebooks on VS Code.
Yeah, but do you download these notebooks?
Yeah, I downloaded from there. Yeah.
When do you download these notebooks?
Last night.
Oh, and interesting. Is everyone having the same problem?
No.
Yeah, how about another problem?
Yeah. Maybe we can. Yeah, like you want to share your screen or? I think with debugging, is like if we spend a lot of time on a single person, I think everyone is gonna get bored. So maybe send me an email.
So maybe like if you guys are having problems, we can try a bit, but if it would also be good to kind of continue a bit and see a bit more about Gdsfactory.
Yeah, because the worst case
I installed Gdsfactory on my base.
Okay, yeah. We can continue with so what I was planning to show is mode solver, and then circuit simulations, and then we do a ring and an MCI. So I think we have only 30 minutes.
Yeah, that sounds good.
Okay, so for the mode solver, we have 2 options. I mean, the DRC we can also run pretty fast, because it's basically you basically write the DRC deck, and then once you have the DRC deck, you can basically, if you have Kelly open, so basically the first thing we do here is we write the DRC deck that basically defines rules, and whenever we do this write DRC deck, it will automatically store it on your K-layout technology. folder. So you can see my user name, I have a generic LYDRC. Then I'm going to make a layout that has errors. And I'm going to show it here. I do plot to see here, but I show it also in Klayout. So once I have it in Klayout, I can do tools, DRC, and I can do generic DRC. And I see, for example, I have 8 errors. And this basically is very nice. It's a marker browser that I can go through the errors and I can visualize them. And every time I click on an error, like minimum space, it will tell me exactly where it is by flagging it in red. So these are errors that will not let the Foundry fabricate your design, so the Foundry will push back. So it's very nice to be able to write DRC text from Gdsfactory.
One question.
Yeah.
Can we use, is there any support for Foundry decks?
Foundry.
Like, for example, we're using one of the foundries. Can we have to use the DRC deck from the Foundry and load it somewhere instead of writing it ourselves?
Yeah, some foundries provide a DRC deck for their process. Some foundries don't. So if they don't, in some of the, you should maybe contact the foundry and CC me at contact@gdsfactory.com and like try to see if they have it. If they don't have it, yeah, we may have done it on the Gdsfactory PDK, but if not, I can give you guidelines on how to do it. But it's a lot of work. Specifically, every foundry has many layers, and every layer has many rules. So it's actually better if the foundry is the one who builds the PDK and the DRC deck and maintains it. But if you build your own DRC deck in Klayout, you have to make sure that as the foundry changes the process, you have to make sure the DRC deck stays up with the process. So that's also something that as a user, as a designer, you are paying money to the foundry, so you should be the one asking for this. And if the foundry gets a lot of requests like yours, if a lot of people are asking for DRC layout decks, they will put effort. But it's only like a handful of foundries that are supported at the moment.
My question was like, the foundry actually provides a DRC deck, but it's maybe not suitable for the Gdsfactory. And
the Gdsfactory just generates DRC decks in Klayout, but it's Klayout who runs them. So when I go here, I just go to tools and then run it. The only thing that I do with Gdsfactory in the notebook is to write the deck. So it basically,
that's the question.
It's to write. But this is only if you are writing your own DRC deck. But if the foundry provides it, you don't have to write it. So you just basically run it directly on the DRC engine here.
But the decks that you run are basically Klayout decks.
Exactly.
Correct. Yeah, they're Klayout decks, and you need to run them in Klayout. But Gdsfactory is
how many foundries offer Klayout decks? Because I know they all have Calibre decks, but how many have Klayout decks?
Yeah, it's a handful. So yeah, there's a handful only. Yeah, maybe like 25% of foundries.
Is that because it's actually IP or it's like a NDA rule between the foundry and Klayout, so that it's not spread out to the others?
The
NDA rule.
The DRC and most of the PDKs I was showing here, they are under, let me go back to Gdsfactory, the main page. Most of the foundries that are listed here, they distribute their PDKs under NDA. So the PDK includes layers information, they include like a design manual, and they include also the DRC deck. And some of them also simulation models and other things. But all these things, you need to get the NDA with the foundry, and then you can ask them for the Gdsfactory PDK. But yeah, they will not be available unless you go with one that is basically open source. So there's a few foundries, like for example, Cornerstone. I will show the circuit simulation with the Cornerstone PDK, which is fully open source. And you can see that we have multiple like flavors of the process, and you can see them. We have examples, and we have also Klayout DRC decks. I think maybe the 220 I think has one. I think. Yeah, maybe I didn't include the DRC deck in this one, but these ones have DRC decks and they have everything open. So this is what you can check for yourself. These are a good example how to build a PDK. And I don't know if that answered the question.
Thank you.
Okay, nice. So now that we run the DRC, we're gonna go to the next notebook, which we're gonna run a mode solver. So the mode solver, there's two mode solvers that we have on the training. The Gdsfactory one allows you directly to basically from a component in Gdsfactory directly mesh it and directly run it. And this is the same one we will be using also for solving like thermal simulations. But yeah, it's very nice that you can basically from layout being able to solve modes and then be able to compute them and they show the fields. You can also sweep modes. And we have sometimes, yeah, these ones, if you find a lot of modes, it can be a bit slower. We haven't run this in a while. But you can see here you have the meshing of the waygate. You have like the waygate is silicon and it's surrounded by oxide and it's also surrounded by box, which are both silicon dioxide. And you can define what are the materials for the mesh. And then you can see here the refractive index. Yeah, it's actually epsilon. And then you can compute T fraction and modes. Yeah, this may take it's taking longer than expected. I think we may have to forgot. Yeah, I haven't run this in a while. Oh yeah, I finished. Maybe we run it with very high accuracy. So you can see here the real part of the E field of the first order mode, and this is the TE10. So this is the second T mode. We also have another finite different domain. This is basically the tidy. It's a FDFT, finite different frequency domain. And here you can do exactly the same thing. So you basically define a waveguide. This is also very useful if you're gonna do FDD simulations. You can make sure that your sources you're injecting the right mode and you're collecting the right mode. So you can do things like a waveguide, and you can see the plotting the effective index of the waveguide. So this one is a rib waveguide. This one I was showing before is fully etched. So it's basically a strip waveguide surrounded by oxide. But you can also do one that's basically like has a slab that you can compute, and you can also see the modes and refractive indices. You can sweep. So we have some exercise, but because I only have 20 more minutes, maybe like the mode solver for bands, you can run it on your own. I don't know. I mean, sometimes what we do for this workshop is that people try to run them by themselves before the workshop, the notebooks, and then what we do in this workshop is like we have kind of like questions. So,
I have a quick question.
Yeah.
Like you mentioned about basically Gdsfactory has a wrapper around the API of Tidy2D, for example, to basically. So can you customize simulations as much as you can with the native? Do you have like wrappers around every single function that Tidy3D offers? Can you customize all the same parameters, same types of simulations, and so on?
Yeah, they basically returns a Tidy3D simulation object. So it's basically like we can see this, for example, like we create a component, a coupler ring. We can plot it. What we do is we basically define a Tidy3D component. So we have this Gdsfactory. So we basically import the Gdsfactory plugin for Tidy3D as GT, and then we just define the component, the layer stack. This is what I was showing that enables the 3D. we define the material mapping because we have a mapping in our layer stack. We call things silicon, and then I need to map it to the Tidy3D material. And the nice thing of this plugin is actually it's maintained by the guys from Tidy3D. So it's basically, and this is one of the beauty things of open source, because both the Tidy3D API and the Gdsfactory code is open source. All the interfaces are public, and people can improve them. But you can see all the cross section. This is the cut. This is the side view on Z. One of the axes. This is the cut in X. This is the cut cross section on Y. And you can see both Z cross section with X and Y. And then basically what you can do is you can define things. You can see even you can add things as sidewall angle as well. And you can get bigger cross section. You can see the mode fields, and then you can write as parameters. And yeah, this is pretty, in my opinion, one of the best Gdsfactory plugins. And basically will do full S parameters. Some of the pictures look a bit big. Maybe we should review this documentation. But yeah, automatically you can take a whole PDK and simulate the S parameters. And this will allow you to do what I'm going to show next. It's our circuit simulation with SACS. And this allows you to do Gdsfactory compatibility because SACS and Gdsfactory use the same syntax for netlist. So that's one of the nice things of Gdsfactory being open source. We already have a format for defining netlist, and SACS, when it came out, they really like Gdsfactory, so they use Gdsfactory netlist to describe the. So we're going to do something like this with the Cornerstone PDK. So we're going to do take a component like this, extract the netlist, and then every element of the netlist, this coupler, this bend, this trait, will have an S parameter model. So we will be able to simulate a spectrum. And we can change the layout, like the delta length, and we will be able to simulate another spectrum. And this works for models that are defined with equations, models that are based on simulations, models that have things like variability, like Monte Carlo, like width and height variability. So you can see how wafer variability turns into circuit variability. For example, if you do the layout of top and bottom arm far away, there's a lot of variability, like 0.8, 1.8 RMS. And if I make a compact version of the same component, I get 10 times less variability. And I can also do phase shifter optimization, like a heater. And as I apply heat, I get a phase shift. And these are things where your device simulator, like I was talking about Femwell, we have examples here on how to do thermal. But if you also want to do things like I think you guys work on like nonlinear polymers, it will be very, very similar to the lithium now with phase shifter example, where you basically apply a field and then you get apply a voltage, will change your refractive index. So you just need to create your basically stack circuit simulation model. Like in this case, it's like a phase shifter model, has a, depending on the power per pi of the heater, you will get a different phase shift depending on the voltage that you apply.
I have a question here. I never used the SACS before. So it's actually very similar to the numeric interconnect, right? It's a circuit simulator. So for numeric interconnect, actually the ecosystem allows you to use the S parameter generated by, for example, FDDT, other solvers. So what is SACS, like the S parameter use? Where it gets the S parameter from? Other software, or it also has its own solvers to directly generate these S parameters?
Yeah, very good question. Like SACS uses these parameters from any FDD simulation. So it takes, and this is the nice thing I was mentioning before, Gdsfactory standardized the interfaces with all these tools. So you don't have to learn the MIP and Tidy3D and numerical API. You directly from Gdsfactory, you write these parameters. Okay. So it will accept any of these parameters. So whenever we do circuit simulation with SACS, we have an example of how to take, this is a simulation with numerical, but it could have been done with MIP or it could have been done with Tidy3D. It doesn't really matter. And that's one of the beauties of Gdsfactory plugin. having a common API. So what we do is we take the S parameters from the F3D simulation, and then we fit the model.
Okay. Maybe a following question is that so the workflow is not from numerical to generate S parameter and load it to the SACs, right? And it's all done through Gdsfactory?
Yes, it's done with Gdsfactory, and if, for example, if you have a numerical or Tidy3D license, you can use numerical or Tidy3D. But if you don't have a license, you can also use MIP.
Okay.
So that's one of the beauty of the plugin ecosystem, in my opinion, because we have many users who use different tools, and like we don't want to limit them. Like if you use basically MIP or Tidy3D, or let's say you want to use something like we've been also doing some things with device optimization like Elmer or Palace. So these basically are also I think these ones are basically FEM RF simulations tools. One of them is from AWS, and the other one, I don't know who maintains them, or Palace. So these ones are other simulators that we also have interfaces. But the nice thing of Gdsfactory is that if you want to use another simulator, like this is one, for example, is pretty new, the F3DZ, you can also make your own plugin, and we have examples of how to make your own. But in my opinion, we have covered most of the simulation extensions that most people use, especially for photonics, quantum and analog, I think. Yeah, I think some people even use it for MEMS. But, so now what I'm gonna do, so I'm gonna take the PDKs, the CS PDK. I'm gonna take the Silicon 220. I'm gonna do an example of how to from a component, like let's say I'm gonna do a delta length MZI of 50. I'm gonna extract the netlist. I'm gonna run a circuit simulation of the S parameters. So here you can see the layout. We extract the netlist, and you can see the spectrum of an MZI, so you can see the fringes. So I can also, let's say, instead of 50, I can cut this. I can use a delta length of, let's say, 25. And I can do exactly the same thing. I can show the layout, I can get the netlist, and I can do a SAC circuit simulation. So this will do exactly the same thing. It basically extract the netlist, and now I have less fringes. So I have reduced my FSR. So yeah. And this is very nice because you can scale to very large circuits, and you can combine actives, and yeah, it's a. I was using other simulators, but I've been using Gdsfactory for the last five years, and I've been using SACs for the last 4 years.
How many PDKs come with the models already, or should people run the simulations themselves before being able to use SACs?
So yeah, we are helping multiple foundries with SACs PDKs. So Gdsfactory, most of the PDKs, when they include models like the Cornerstone I was showing, this is possible because if you go to the Cornerstone PDK, PDK for home plug, we can go here. You will see there is a folder called models, and this basically includes the models of all your circuits. So this basically has a straight model with a loss and a refractive index, effective index, and group index. So it's a dispersive model, and it has also band models with loss. It has taper. So these are very simple models because this is an open source, very simple PDK. It doesn't, I think, yeah, it has heaters, but we didn't add any heater because the heater that they have, yeah, we didn't get the power per pi, so we haven't simulated. But this will be something that we could simulate very easy with FEMWell. Actually, we had that in the tutorial, but I don't know. We have only 9 minutes. But this basically allows you to do finite element simulation and calculate what the power per pi of your heater. People can want to see, but this will take the layout and directly give you the power per pi for the model, and then you can put that into the SACs model. So we have a full multi-physics. So Gdsfactory basically started as a layout tool, but because we got so many people using it and so much traction, like thanks to the community of like 65 developers, we were able to put together a very extensive plugin ecosystem. And then the beauty of this is that I haven't written most of this code, most of these plugins, and it keeps growing and people keeps adding things. So if you guys have a specific tool, I know a few people who are working on a few more plugins. Like I know people working on the device simulator for numerical. There's another open source one with DevSim that's also coming out soon. So this is a TCAT solver. So yeah, I highly recommend that if you want to do something like this, you can also share it if you want. If you don't want to share it, you can also keep it secret. We also have some secret plugins that have never been shared. But it's up to you how much you share, or you can just use it. And yeah.
So did you have anything else you wanted to show in the next last 7 minutes we have before we need to head off, or we can open up for questions as well? Or?
Yeah, that's what I was like. It's better if you have any questions. Like, I can just talk about Gdsfactory for hours because there's so much material. Even running through the whole notebooks that we have on the Gdsfactory itself, it could take 2 hours, and then the plugins could take another 10. So I show kind of like a few of my favorite plugins, but there's also other ones that I use.
Excellent. So it looks like this is all very well resourced online, but I think we just got a question come in from.
But yeah, I see it's on chat. Let me see. I'm not super familiar with. Okay, yeah. Which plugins for heater simulation? Yeah, for heater simulation, we use Femwell, which can handle also very big chips. So if you go to the device simulators, you have the thermal one, and then it will basically, this will run through the nice thing of this is that directly from the layout, we extract the mesh, and then we can do mesh refinement, and we can compute the thermal profile, and we can also see as we inject current how much refractive index we change. And we have examples also. This is in 2D, but we have done this in 3D as well. And I think we would like to, yeah, one of the developers for Gdsfactory wanted to add a notebook. Yeah. There's also a lot of things that are not as documented, like for example, all the quantum plugins. I haven't used them, so I don't know how well documented they are. For example, we have some these electrostatic ones. I haven't used them too much. I don't think I ever even installed them. But yeah, the fact that a lot of questions that we usually get is like the fact that the tool is open source, like you still need a numerical license. So like if for example you don't have a numerical license, this won't work. So you need to be aware that this will basically not pop up anything. Will basically, you need to have numerical installed, you need to have a license. But with MIP, you can also just install it with the Conda installed, and then you can just use it. Can see. We even have examples where how to do like grading couplers and see like the spectrum. But yeah. I mean, I hope you find it as useful as I have been using it for the 5 years. Yeah, I'm surprised in the US is I think most of the universities are already using Gdsfactory, but yeah, I think in Europe it's I think it's a bit slower the adoption. But I think a lot of universities are already changing here as well in Europe.
Yeah, well, I mean, you get to talking to everyone in Europe here, so there you go. Maybe just one last quick question from the chat about doing non-Manhattan routing with Gdsfactory's route function. Is that possible?
Yeah. We have a non-Manhattan router. So a non-Manhattan is when you want to do a diagonal. So if you go to the documentation, we start basically, if you go, it's a part of the layout tutorial. If you go to routing, we start with route single, like how to route a single route between two components. you can also, I mean, sometimes when you route this and you have obstacles, you can also define steps when you turn. So you can go around obstacles. You can route bundles of components. I think this is super useful to basically make sure groups of routes don't cross. And then we have the route all angle here at the end. The route all angle will allow you to route things that are on a diagonal and things like this. These things are kind of like, in my opinion, very hard to do in other tools. You end up with 1 nanometer gaps all over the place, and those create DRC errors. But with Gdsfactory, we have solved this years ago.
Yeah, okay, we'll go one last question and then we'll probably have to run off to the next session of talks.
Is there a tool in Gdsfactory to do kind of acute angle filling or that sort of stuff? Like filling acute angles or small gaps that are against these angles?
Yeah, we call that data prep. Yeah, so if you go to the plugins, we have a data prep that allows you to do that. In Gdsfactory, it's actually very easy to do that. I mean, I can maybe show you if you maybe in the layout tutorial we already show it. If you go to the layout tutorial, I think it's part of the geometry where we basically do over and under. So you can see you're referring to these corners, right?
Yeah, right.
So yeah, we basically do this, but it's 2 lines. So you basically size it, you over, under, and then basically this will merge.
Yeah, but you also need to round, I guess, otherwise some angles it still gives some problems, or it depends on how many points you've got in the polygon.
Yeah. The regions allows to simplify also, and it allows you to round. So we have this. If you go to the round corners, it's as easy as like a P polygon round corners, and then you define the radius, and it will basically round it.
I think maybe the question is also how do you detect them? Like if you don't know they're there.
You use operation everywhere.
Yeah, these are DRC. The DRC will catch it, but you need to either. I like to fix them at the component level, at the cell level, but there's also people who like to fix them because sometimes they happen in routes or top level assembly. So some people want to fix them at the global mask level, and we have this with the. We have done this in the same way that we can do dummy fill. So we have ways to, at the whole mask level, be able to over, under, remove layers, smooth, do booleans. But yeah, this is part of the plugins because we could also move this part of GDF. This is the kind of plugin that could be in either place. But yeah. Thank you.
Excellent. Okay, well, we might have to leave it there, but thanks very much for your overview of Gdsfactory. So there's a lot to look at in addition to this, but very good overview at the least.
Perfect. Thank you for inviting me, and looking forward to meeting you.
Thank you.
Bye.
Bye.